The structure of the Earth is divided into four major components: the crust, the mantle, the outer core, and the inner core. Each layer has a unique chemical composition, physical state, and can impact life on Earth's surface. Movement in the mantle caused by variations in heat from the core cause the plates to shift, which can cause earthquakes and volcanic eruptions. These natural hazards threaten lives and property. Learn more about how the Earth is constructed with these classroom resources. Now let us explore the Earth's crust. The Earth is not just a solid ball of rock. That rock is made of layers characterized by different elements and different types of rock that are either solid or fluid. It also possesses different temperatures and thicknesses. The outermost layer of the Earth is the crust. It is thin compared to the other layers, a little bit like the peel of an orange. Unlike a fruit peel, the crust is broken up into several pieces called tectonic plates. These plates move relative to each other so that the surface of the Earth's crust is always changing, although very slowly. Well, there are two types of crust. The first one is what we call continental, and the other one is oceanic. Continental is that under the continents and other large land masses like Greenland and Madagascar. The other one is under the world's oceans. Continental is said to be less dense and lighter than oceanic crust, while the other one is said to be denser and heavier than the continental. Let us compare the characteristics and components of the crusts. Continental is said to be older for about 4.4 billion years old, composed of granite, which makes it less dense for about 2.7 gram per cubic centimeter, while oceanic is said to be younger for about 200 million years old, composed of basalt, which makes it denser and 3.0 gram per cubic centimeter. How do basalt and granite form? Well, let us know how. First is oceanic crust. It is made mostly of basaltic rock, and basalt is a volcanic rock that is formed the oceanic crust as the mantle. The molten rock under the crust wells up and hardens. This happens at mid-ocean ridges where the crust is being pulled apart due to the motion of tectonic plates. Oceanic crust is about 4 miles thick. What about granite? Now let's tackle about the continental crust. Oceanic crust may be heavier and denser, but continental crust is thicker and older part of the Earth's crust, which is mainly most of granite. It is a mineral that is a major component of continental crust. The crust of the continent is much older than oceanic crust. Unlike the ocean floor, continental crust is not constantly reforming. You can find rocks as old as 4 billion years in continental crust. Are you curious why does oceanic crust always sink? Because oceanic crust is denser than continental crust, it is always sinking relative to the continents. New ocean crust forms at mid-ocean ridges, but old ocean crust gets recycled in regions called subduction zones. These are tectonic plate boundaries at which two plates are moving toward each other rather than pulling apart. When ocean crust meets continental crust at a subduction zone, the heavier oceanic crust sinks under the continent and becomes part of the molten mantle again. Well, do you want to know more about how do plates move? Don't worry, we will help you understand plate movements in our next virtual session. I hope you grasped something important things about Earth's crust. Now, do the given activity. Goodbye!